Okay, so what I want you to do is I want you to draw just a circle in the middle. Just as normal as you can make it. This is equivalent to, let's call it a parent function. Okay, what I mean by that is we haven't done nothing to this circle. It's just a circle, okay? Just like these shapes. They're at their natural state, parent functions, okay? So that means that A is 1 and B is 1. When we say it's in an original state, that's what it's 1. 1 doesn't change anything. What's 1 times 100? 100, you didn't change it, that's a 1, okay? It doesn't do anything to it. So there's only two things we can visually do to this circle, okay? By the way, this is the same for, like if you're doing like, well, how is that a parabola? Like, how do I apply this to a parabola? It's the same pulling and stretching. So like, if you're doing a parabola, it's like this part. You know what I'm saying? You just kind of apply it to the circle, okay? So there's only two things we can do to the circle, okay? One is, we can make it long, like this. The other is, we can make it flat. So there's not a third one. There's not like a, I'm gonna erase this one, but there's not like a sideways one or something like that. Okay? So it's either this one or this one. Okay? Those are the only two effects you can do. So here's what happens. Out of memorizing, this is the only part I need you to memorize. This happens when A is greater than 1. And then lucky for us, it's the same exact visual when B is greater than 1. So whether it's A or B, if they're either one is greater than 1, that's what the circle looks like. Okay? Now, what if 1 is the natural state and bigger than 1 is the other? What would be this? What causes this? Less than 1. Would that include negative numbers? That's a kind of a tricky question, okay? The answer is no, because we already know what negative numbers do, okay? So it's only from 0 to 1, okay? And the way we write it is like this. 0 less than A less than 1. That means A has to be a number between 0 and 1. What such numbers are those? Decimals. Examples, so like 0.3, fractions, like 1/2, right? Those are numbers between 0 and 1. Okay. It's the same shape for 0 less than B less than 1. So it's the same for B being a fraction or a decimal. So it doesn't matter if it's A or B, either one. Everybody on board with me? Same page? Okay, this next part is the most important part of this whole notes. Okay, this is the part I need you to really focus with me. Okay, so here we go, okay? You have to look at your formula. Is A inside or outside? Outside. Who else is outside? X or Y?
Y.
Everybody see that? Okay, is Y like this or like this? This is the Y, right? Is that called vertical or horizontal?
Vertical.
Okay, this will be called a vertical something. I'm about to show you. Right now, I just want you to know that A is vertical and Y. Does that make sense? Why it's vertical? Because it's the Y. Okay. So this one is also going to be called vertical. Vertical something. Are y'all good with why it's called vertical or something? Now I'm going to show you the stretch and compress part. Okay? So vertical means the y-axis went like this. The y-axis went like this. You showed me with your arms just now. So that means I have to grab this circle by the vertical ends. And I ordered this super very elaborate technical thing to show you this. Okay? All right, so vertical, top and bottom, okay? What do I have to do to this to make it look, right now it's at this state. So what do I have to do to make it look like this if I have to grab it from the top and the bottom?
Stretch it.
Stretch it, pull it. Everybody agree with that? Okay, that's called a vertical stretch. Because that's what you did. You vertically stretched it. Okay? Or, let's think about this. A's are bigger than 1. What is the A doing? Adding or multiplying? Multiplying, right? So you're multiplying the y's times the number. So 2 times the y, 2 times 3, 2 times 4 is making those y's bigger and bigger and bigger. Okay? Over here, what do I, so again, you have to grab it from the top and the bottom. What do I have to do to my fingers to make it look like that? Push, compress. Everybody see it? Compress. Okay, so this is a vertical compress. So on this one, and you need to put this on your nose, you're stretching it, so you're pulling it. And on this one, you're compressing. Right, or if you multiply the y's by a fraction, it's making those y's smaller. So the y's are getting smaller, smaller. Okay, let's move to the b. The b's always the harder one. So remember, let's get these down. The only part you need to remember is if it's greater than 1, it looks like this. If it's 0 and 1, it looks like that. And this is the last part, guys. Okay? You just gotta play along with me. Is the B inside or outside?
Inside.
Inside. Who else is inside? X. X, right? This X looks like this.
Yes.
What do we call this? Horizontal. Okay. So horizontal is like this. So we're gonna call this horizontal something. This one's like this. Now I had students just last period still trying to memorize. And when we started doing it, bless you, when we started doing it on our own, they started missing it because they weren't picturing this. Okay, so don't try to memorize, try to understand. It's just, once you get this far, it's just common sense now. Okay? If I have to grab it from here and from here, you really have to picture this, right? From the sides, what do I have to do to my hands so that it looks like this? Push it, so it's a horizontal compress. Okay, so horizontal compress. Notice I'm not memorizing anything, I'm just seeing the actual effects. So I'm pushing from the two ends inwards so that I'm squishing that circle. Everybody understand why I'm grabbing it from the sides and not from the top and bottom? That makes sense. Yeah, this one affects the X, not the Y. Inside, outside part. Okay. Now this one, again, I have to grab it from the same part, but what do I have to do to make it look like that? Stretch. So horizontal stretch. Okay. So I'm pulling away from it. Are we good? Make sense? Okay. Any questions? Okay, we're gonna do part 4, which is the examples.